We are told in this problem to transform a piecewise function. And the piecewise function is shown in black, it's f of x. And we're told what kind of transformations have to happen on it with this equation right here for g of x, the transformed function. So it's like you're treating f of x like a parent function, except this thing looks way uglier than any parent function we've dealt with before. It's not a nice x squared or absolute value or anything like that. It's a piecewise parent function. And honestly, this is really where this unit starts to wear on me, because we're going to have to transform a bunch of things in this picture. And the easiest way I've found of dealing with this is to do it one point at a time. How many points do we have? Well, let's take a look. I'm just going to draw some points on here. And this is not what you would enter in the graph as your answer, but I'm going to use these points to talk us through how we solve the problem. Now now that we have the important points located, let's now talk about what's happening here. So I have a vertical reflection. And you can see that with this negative sign right there. And I also have, let's see what else we have. We have a vertical, that's a compression, because it's a factor of 1/2. Vertical compression by 1/2. If it were greater than 1, it would be a stretch, but it's not what we got. So now, what else do I have? I have a vertical, sorry, that's not vertical at all. That's inside parentheses. That is a horizontal reflection. And what's more than that, we have an equation here that was written in an intentionally tricky way. If you look here, see this negative x minus 2? We really want to factor out that negative sign. So let's go ahead and do that before we get much further into this. This is negative 1/2 f negative x plus 2. Okay, see how I did that factoring right there? It's important to factor that out because now we can see that this is a shift to the left, right? It is a shift to the left, not a shift to the right, as we might have first suspected. So that plus 2 right there is a horizontal shift left, plus goes left, shift left by 2. And our last bit of this is, where's the color I haven't used yet? Obnoxious green. This minus 4 right here, that's an easy one. That's just vertical shift down by 4. Okay, so now that we know what's going on in this picture in terms of a list of transformations, I'm going to take that list and apply it to each of these 3 points in the picture. And once we finish applying it to the 3 points, we'll have our new picture of a transformed function. So let's start on the left. It does not matter, kind of matters. It doesn't really matter where you start. I'm just going to start with the one on the left. We're going to vertically reflect this guy. Okay, that goes down to here. Okay, and then I'm going to vertically compress it by 1/2. So that's going to move it up back to this point right here. And when I'm doing this on a computer screen, I really do go step by step like this. Now I want to, where's something else vertical? We'll just go in order. Just go in order by these things right here. Okay, now I'm going to horizontally reflect this point. So that's going to take it all the way over to here. Okay, horizontal reflection. It goes all the way around the y-axis like that. Okay, and now I am going to, so I've done this, I've done this, I've done this. I'm going to shift it left by 2. And I'm going to shift it down by 4. 1, 2, 3, 4. Okay, and now once you know that's where it's going, you click on that spot. Okay, that's this dot right here. And now, don't lose track of what you're doing. We're going to move on to this dot next. So let's start working down our list again. And I didn't put red check marks there, and that's going to bother me because I'm just that sort of person. Okay. Now, vertical reflection of this dot. That's going to move it to this location. Done. Vertical compression by 1/2. That's going to move it to this location. Done. horizontal reflection. That's going to bring it over to this side. Okay, done. And let's get rid of some of those things. Now I want to shift it left by 2. Done. And down by 4. 1, 2, 3, 4. Okay, so there is the second dot. There we go. And now we can move on with the final dot, which we will do in purple. Okay, I did it again. Okay. First, we vertically reflect it. So that's going to go down to -4. Right here. Okay, done. Compress by 1/2. And then horizontally reflect it. That's going to do these series of movements. Done, done. Okay, now I'm going to shift it left by 2 and shift it down by 4. 1, 2, 3, 4. I bet you think I'm going to forget to check these things off, but not this time. Okay, so we erase those, and that is the final location of the purple one. Now, if you were drawing these using the graphing utility in the computer, you should have drawn a segment, right? We're using a segment tool now. It would have looked like that for your first one. Then you would click on that blue dot again and connect it to your purple dot. And that is this picture. And if you take a look at it, it should be a little satisfying to know that this does make sense. If you think about what happened here, it got vertically and horizontally reflected, which is like the whole thing got turned around, and you can see that, right? The whole thing got flipped over right here. And then some shifts and compressions happened. So on this problem, you spend enough time on it that I would encourage you to double check your work, especially if you're in a test. So just keep that in mind.